Welcome to VideoSDK, Video KYC tutorial. Using a Video SDK, you can build an end-to-end VKYC application where both agent and customer can interact, where agent can verify all the important details that are required from the customer. Let's try to run this application and let's see how it is working. As you can see, it is running on localhost 3000. Now let's see the workflow of this application. Let's start by understanding what Video KYC is and how it works. Video KYC is a remote verification process that replaces traditional in-person identity verification. So here's a typical workflow where agent first creates a room, then it sends an invitation to the customer, and then customer join using similar methods. So as you can see, this session state is managed by Video SDK server, and there are other features. Once agent and client are part of this meeting, so they can record this session. They can do a whole bunch of stuff like capturing a document or asking verification-related question. And you can also record the session if needed for compliance. So all the interaction happens in real time with data securely transmitted through Video SDK server. Next, this is the architecture of our React application. So this application is built using Video SDK's React SDK. So this is the structure of our entire application, where all the components are wrapped inside this app component. And this meeting app provider is context provider, where we stay. We store some common state that can be accessed by other component. Similarly, we have this meeting provider. So it is accessed from Video SDK's library, where, we can provide some common state related to assess and like, what is the name of participant? What is the meeting ID? What is their participant ID? So this is a basic architecture of our application. Next, let's understand what are the common components. First, let's start with the joining screen component. We have three major components in our application: joining screen, meeting view, and leave screen. So in components and screens, you will find joining screen components. Here, the joining screen component in our application serve as the pre-meeting setup area, where both agents and customer prepare their device before entering the verification process. So here, this is a method from Video SDK library where we check for whether camera or mic they are enabled. If they are enabled, then we can set them to local state we defined for camera and microphone. And if they are not enabled, then we can re-request for both audio and video. Now let's see it in real time. So this is the pre-meeting setup where we can request for camera and microphone permission. So this is the video preview so user can position themselves correctly. And user can select different devices through this simple selection. So there you will see all the available options for microphone, for speaker, and for the camera. And here we can also check our network quality before joining the screen. Next, let's see some component related to VKYC. First off, let's start with network stats component, which is crucial for VKYC process. So let's look at how it works. This component continuously monitor the connection quality between participants, providing real-time feedback on network condition. So here, as you can see, we are measuring the upload and download speed, and we can access this value through this getNetwork method from Video SDK. So we can invoke this method in a particular duration. So here we are invoking it in every 45 seconds, and we can display different status based on the network condition. So if we are checking for network, then we can display that we are checking for network. If we are connected, then we can display the download and upload speed. And if Wi-Fi is not on and there is no internet, then we can display this status that you are offline, or you can customize it according to how your application behaves. So this is an important component. It is used to measure the network stat. So if call is failed during a week KYC process, we can identify what is the main reason. Next, two major components are image upload listener and image capture preview dialog. So the image upload listener component works behind the scene to enable secure document sharing during KYC session. So here's how it functions. The component listens for image capture request and handles the entire capture to sharing workflow. The beauty of this component is how it handles complex process invisibly to user. So as you can see here, what we are doing, we are preparing some metadata for this image, like what is its name and where it is, published. And finally, we are uploading this image. So we are transferring this image. So if you check out this image upload method, it is a method from use PubSub. If you are not familiar with PubSub, is a collaborative feature provided by VideoSDK where we can subscribe to one common topic, then we can send and receive messages. So that's exactly what's happening here. And in image capture preview, we first fetches that URL. We convert it into base 64, and then we set it to image source so that we can see how it looks visually. So that's exactly what's happening here. So the message sent here, we can receive that through this own message receive event. We can fetch the URL of the image. If you want to see how it look in real time, as you can see, we have this feature where we can enable or disable front and back camera. Now the beauty of this feature is, during weak KYC process, sometime customer find it really hard to switch to a back camera. Then this feature is really powerful. And we can see all the images that are captured here in this image panel. And it is important for capturing the document for verifying the signature of the candidate. So this is how these two components work. So we have seen the workflow, what is the architecture of our application, and some important component related to VKYC. Thank you for watching.